And we're recording. Alright, so welcome to week 4, where we're introducing you guys to 3D printing after the previous weeks, which were all just modeling. So hopefully with Intro to 3D printing, we can get you guys started on actually printing any models you want, or any models that you have already. So first off, we're gonna start off with what 3D printing is. So it's a form of additive manufacturing where the other forms would be subtractive and formative. Subtractive manufacturing being like CNC machining, where you're cutting your parts out from stock metal or material, and formative machining being like injection molding, where you have a mold and then you inject your molten plastic into there and then take it out of the mold. So, and for 3D printing, have you ever seen videos of it, or you can search up real quick, what you do is you have essentially like a hot glue gun that spits plastic out, and then you just keep doing layer by layer until it builds up into the object that you want. So there's 3 different types of 3D printing. From top to bottom, it's going to be the cheapest, starting to get cheaper, and the most expensive. There's FDM or FFF, which is fused filament. These are going to be 3D printers that you can buy at home and use at home, and the main stuff that's available to you. And that's what I described before, where you have your plastic that gets heated up, and then layer by layer you build it up into the object that you want. There's also SLA or resin printing, which is you have a vat of resin, and then at the bottom of that vat you have a screen that emits UV rays, and you emit the rays in a certain pattern, and then same thing, you just build it up layer by layer until you have the object that you want. And then there's SLS, which is selective laser sintering, and this one's actually pretty cool. You have essentially a tank of powder, which is usually like a nylon powder or some sort of polymer, and then you have a laser that shoots into the powder, and it goes, not sure how fast it goes, but it's pretty fast. And what it does is it will melt the powder into whatever object you're looking for. Let me get that. All right. But for now, we're just going to focus on fused filament, because that's what is available at the Makerspace. The Makerspace also has SLA, I think. You'd have to ask around for that, but for the most part, you'll be using FDM or FFF. And so 3D printing is actually pretty cool, especially since you can get the printers at home. The main pros of 3D printing and being able to 3D print is that you can make relatively complex designs pretty fast compared to machining, where machining, the more complex you get, generally the more expensive, where something like this elephant right here, if you have a 3D printer, you can make that in 5 hours and 20 bucks, where machining, it would take about a day and at least 200. So that's quick and inexpensive, and there's less waste, because with 3D printing, you're adding material on, where with machining, you're taking away, so you have a lot of like metal shavings or leftover material that you can't generally use. But with that comes some pretty massive cons, where mass production costs more. So let's say you want to make 20 cubes. If you're doing that through machining, all you really need to do is get your material, cut it up, and depending on how it's shaped, it's going to be pretty quick. But for 3D printing, you have to take time to basically make all the cubes from scratch. So it'll take a lot more time, and most of your money is going to be used in not material, but actual production cost. And then also with 3D printing, there's less material choices. Because, let's go back a couple slides. So yeah, with 3D printing, you're heating up something, melting it, and then putting it down. So you're really restricted to things that you can melt. So most of the time, 3D printing is going to be using a type of plastic. I think the makerspace right now only offers PLA, which is a corn-based plastic, and PETG, which is like the same plastic they use in water bottles. And then NextCon, which is pretty big depending on what you're doing, is the final product is not going to be accurate or as accurate to your model as machining is. An example being this picture right here. So this is just a hole or square with a hole in it. Problem is, your hole right here isn't completely circular, and because you're squishing plastic down and melting it, it's going to shrink and expand. So some of your dimensions are going to be off by like tens to the hundredths of a millimeter or of a centimeter. So if you're just looking to like prototype, it's fine. But for final products, you might have to do some post-processing or some more advanced modeling, which is, or not advanced modeling, but you're going to have to design models with 3D printing in mind, which is what we're going to get into in a bit. So the main thing with 3D printing, like I said before, is that your final product is not going to be accurate to your model by a few centimeters. Well, not a few centimeters, a few millimeters, which isn't too bad considering you can fix it pretty easy. But the more time you're spending processing your final product, you can like fix within a couple minutes of modeling. And with 3D printing, there's two sides. There's the CAD side, which is when you're 3D modeling, and then there's the slicer side, which is how you turn your 3D model into something a 3D printer understands. So today we're just going to focus on the CAD side, and then next week, hopefully, we're going to get into the slicer side. Oh man, I forgot to add this. But so there's the main consideration for CAD side modeling are going to be holes and tolerances. So I'll stop that. And then I'm just going to open up Inventor real quick. Oh, and if I'm going too fast, or if you guys have any questions, comments, or anything like that, don't be afraid to just stop me and tell me what. Alright, so I'm going to open up the first model that we worked on. Alright, so this is the first model that we worked on with CAD in these sessions. Should be, I think, week 2 or 3. But I'm just going to use this as an example for now. So this, if you guys wanted to 3D print this, just need to open the drawing. So yeah, this model has that one center hole, which has a 15 centimeter put either a 15 centimeter or a 15 millimeter hole in the middle, right here. But when you actually go to print that or make that for a model, it's going to come out more like 15.1 millimeters or 15.01 centimeters, depending on how big you're printing it. And depending on how tight you need it to be, you would want to model in your tolerances. So let's say this is 15 centimeter or 15 millimeters. Let's see. Yeah, it's actually better if I do this in drawing. But yeah, let's say your hole here is supposed to be 15 millimeters, and then once you have it, you're supposed to put a peg that's 15 millimeters round. When you 3D print it, this hole.
Question about.
Someone had a question?
Yes, me, Ricardo. I have a question.
Sure, what is it?
About the. Okay, so I used Inventor before. My issue is sometimes I accidentally press a sketch, or I want to revisit a sketch on a face of a diagram or whatever, but
Alright.
it never finds it when I right click. It doesn't show up like the edit sketch. So how do you? I know you can check right there in the where you have the model. It like says sketch right there, but like, is there a way to like see or highlight it specifically to see which it is
So
without creating a new sketch? Yeah, because that's kind of
yeah.
my issue. Yeah.
So if you go to so here I have my extrusions, and then if you expand that, it should have the sketch it came from. And then from there, if you click the sketch, you should be able to pop it up. Right click and then edit sketch. Not sure if that answers your question or not.
Yes, it does. Thank you.
Alright. So back to the tolerances. Alright, so this is just the drawing. So yeah, So let's say you have a 15 millimeters peg that you're planning to put through this 15 millimeter hole. When you 3D print this part, you want to tolerance the hole. Ricardo, yes, there is a Discord. I'll try to link it at the end. Back to this. So yeah, when you 3D print this hole is not going to be 15 millimeters. It's going to be a little bit smaller. So it might be 14.99 millimeters, something. It might be small enough that the peg might not go cleanly through, which depending on what you want or what you're using for might be good. But if it's too tight, you might have to sand it down. If it's too loose, you might just have to go in there and retolerance it or reprint the part and remodel it. So let's say, let's go into here, and we're just going to edit our sketch. So right now this is at 15 millimeters. And depending on the printer, generally a good printer is only going to be off by a couple millimeters. So you'd want to do it like 15.5 millimeters. Is usually going by halves is pretty good. So you either want to go a full half a millimeter, full millimeter, or whatever unit you're measuring in. And then if it's too big or too loose, you can always go half again. So instead of 5 millimeters, you can go 25 millimeters or 0.25 millimeters. See, there's our. It's not gonna look too different on here, just because it's half a millimeter or a quarter of a millimeter. But when you actually print out your part,
the things you've done in your past, things that I.
When you actually print your part, it's going to be not as noticeable, but when you actually try to put it in, you'll really feel the difference. So, and I actually have a good example right here. So let's see. So stop that video real quick. All right, so let's take this part for example. This is actually a tolerance block. All these holes look the same, but if I take a caliper or some other measuring device to it and just measure the inside, this 6 measures as 16.2 millimeters, where hole 1 measures at 14.8. And I mean, just looking at it, you wouldn't be able to tell that. But if you, in your model, that's something you have to consider. Bring adventure back up. And then, so yeah, that's one big thing you can do in when you're actually modeling. You want to consider how tight or how loose you want the hole to actually be. So change that. And then when you're actually drawing, or when you get to your drawing or your diagram part, you also want to note that in the dimensions. So let's say this hole is 15 millimeters. You'd want to add, let's see what I want to do. You want to do plus 0.05. And that's just in your drawing. So whoever, if you ever want to share your model, you generally want to give them the model and the drawing. And most people will look at the drawing first just to see how loose or how tight the object actually needs to be. And then that's it for the CAD side. The slicer side, it's is a whole topic on its own for now, just because you would need to learn the slice, how to slice how to slice it. And by slice it, I mean, as I said, when you 3D print, it goes layer by layer. So when you slice an object, you're literally just taking your model, slicing it up into different layers so the printer understands what you're doing. But it sounds complicated. It's not really, but it's better off on its own topic. And then this one is the one, if you're going to take anything away from this, it should be how to export your models for 3D printing. And it's pretty easy. There's just one consideration you really have to take in. So let's open this back up. And it's all you have to do is you go to the model, you hit File, Export, and then you want to do it as a CAD format. So Inventor has its own file to save as, which is .ipt, which is inventor part file. I think SolidWorks also has their own file. And then Fusion 360, which we'll go later on, we'll go over later on in the semester, I think also uses their own file, just in their own workspaces. But CAD files are files that are recognized by pretty much every program. And those two are going to be step files and STL files. For now, when you want to export your file to be 3D printed, you want to do it as an STL file. What STL file does is it saves it just as a bunch of triangles, to sum it, or to overgeneralize it. So you have it as STL file, name it whatever you want, save, and it usually asks for course or find, but I'm not sure if it does that anymore, so let's try that again. So export, Cad Format Stl. Oh, quick tip. So when you save out STL, it saves it to the inventor file. If you do this a lot, or you have a lot of files that you want to save, I suggest making another file. So personally, I just have a whole file called 3D Printables, with just everything I've ever worked on 3D printing wise. That's just a quick tip. It makes it just easier for things to find later on. But yeah, it's that easy. Just export CAD format, choose STL, and save. And yes, and it's pretty much that easy for saving it. The hardest part is when you have multiple files, just because depending on your computer, it might take a little longer. And then once that's over, I think most Windows computers have it. It should be 3D Builder. And you can use this to view STL files. So from here, I'm just going to...
Is this used in engineering? I never heard of 3D Builder. Sorry if you explained it already.
I know. So 3D Builder is more so for uh, like animation, but it's the
So, like for
native...
demos, you mean? You could use like inventor drawings and sort of demo something, for like a company, you think?
Yes. Because an inventor, you can... So inventor has... Let's see. In inventor, you do your part, and then you put everything together in an assembly, and then present it. The assembly is good for talking to other engineers, or you're talking with the engineering firms of other companies, because you can send your assembly file over to them, and then they from there they can figure out how to use it. Where 3D Builder, it's not as easy as using Inventor, but you can put everything together in a way that if you have a client that doesn't really understand it, as to say, not to the little non-engineers, but it just puts it together in a way that most people can see it and understand it. So let's say I'll do new scene, insert, add, and then go to load object, load my STL, and there it is. And here's what I was talking about before. When you export it, when you're doing coarse versus fine, it should pop up. I don't know why it didn't this time. But this edge, or this face, should be rounded. And this should be a round hole where you see that it's like flat surfaces. And then in my actual model, it should be perfectly smooth. So I'm going to try exporting it again. That doesn't work. Okay, there we go. Oh, that's not it either. Oh wait, yeah. So here we have resolution. So go options, resolution, and then let's try going for high. Okay. 80EX high. Save that. And then let's try adding it again. Alright, see, it should have worked that time. Alright, yeah, there we go. So here you see it as perfectly smooth outside and inside. It does look a bit, I'm going to say, artifacty. If you ever played the PlayStation 2, you know how some of the models are like really just polygon? So you kind of see it here, but not really compared to this one. So when you do export, CAD format, options, and then high, that should be it. And then, let's see. That should be it for today. I feel like I kind of rushed this, but that's all I've got for now. So if you guys have any questions, comments, don't be afraid to leave them in the chat or just unmute and yell at me.
So Kevin,
Yep.
when we do the project and all that stuff, are you guys going to be in charge of like making the 3D prints, or should we do like the course for the makerspace and do it our own?
So that's something we're still trying to work out. I know for the makerspace, if you guys are comfortable going to the makerspace, I do recommend taking Make 101, which is just the course you need to get into the makerspace in the first place, and then scheduling an appointment to do Make 103, which is the course you need to do 3D printing. It's not really a course, it's really just like a 30-minute presentation that you have to sit through. And the slides I'm presenting for slicing and 3D printing are really just Make 103. So I suggest taking Make 103 and trying to 3D print yourself, just because everyone there is pretty helpful. But if you don't feel comfortable doing that, I can try to work something out with the group, just because I have my own 3D printers which aren't really doing anything, and I don't mind 3D printing stuff out for people and just shipping it to them, just so my 3D printers have something to do. But I'll have to get back to you on that one for a concrete answer.
Okay, so like for now, if we want, just we can do like the 101 on Canvas and then the 103 in Campus.
Yeah.
All right, perfect.
Oh, Cardo, let me get you the Discord link for the club.
Yep, thank you.
But yeah, if you guys don't have any more questions or comments, you're free to leave. I'll be hanging out for a bit just because. Oh yeah, Ricardo. I still have to fight just because. For some reason they don't like letting me invite people, so I'll have to find a link that works. Alright. That Discord invite should work. Alright, yeah, it does work. Okay, sweet. So I'm gonna start recording there.